Hello, class.
Hello, Mrs. Sylvester.
How y'all doing?
All right.
Doing good.
All right.
If you have time at the end, I wanted to speak with you about the exam.
Oh, okay. You had issues too?
Yeah, I had a few issues. One question wasn't displaying the answers properly. Like it had links to a page where something was supposed to happen, and I don't know. A few other ones seemed like I had answered the correct answer, but they were
Okay.
marked wrong.
Okay.
We can look at it after class if that's all right.
Yeah, no problem.
Appreciate that.
No problem. Because I know sometimes uh some of the questions might show like HTML code. But
Yeah, that was one of them.
Yeah, I thought I fixed it, but I'm gonna have to check. I'm gonna have to recheck. Yeah. Yeah. So any questions? Did y'all had programs? Let's see. If you all had programs to turn in.
We had a quiz, a test, and a reading assignment.
Okay, yeah, because I didn't. We were still going over the loops. Yeah, and then like I said, we got. Hopefully, we should complete loops, and I'll assign you your assignments. Let's see. I need to go to.
Also, I had one more question. You posted 2 things on Canvas for the COVID-19 survey.
Well, there's one, but I had to go ahead.
I was just curious if it was one because I did the other one, but I didn't see the other one you posted until later.
No,
but
what happened is I gave bonus, right? And in Canvas, when you create a quiz, how would I say it? In order for it to count, for me, the way I do it, in order for me to make it count as just bonus points added, I have to give the quiz, with with so many points, and then take it out of the or either have it to where it's a quiz that's not counted, and then create a link that's corresponding to it, and then type the answers. I mean, type the values or the scores in it with 0 points. Because make the quiz worth 0 points and give you the bonus points. If you understand what I'm saying.
I got you. Appreciate
it. Because other than that, what happened is I'm giving you a bonus, but you're doing everything, or you're doing it, and it's like a grade, though. It's almost like grading on. Oh, you got 100 out of 100. Oh well, but you said it was bonus. Well, if it bonus, normally it's like added on too, rather than I do it and whatever. So that's why I had to create that other link, other like assignment. It has 0 points, and all I do is take those points and put into that one, and make the other one not gradable.
Gotcha. Thank you.
All right. Anybody else with questions? Questions? Let's see. Let's just review. Single page. So that's why it's continuous. So that's what I want. All right, so let's go down here to chapter 5. And it's loops. And I still want to try to fix this display or enable scrolling. All right. So pretty much we went, we talked about the plus, the minus, how it works, the pre and post, how it works. All right. We got into the loop, the while loop. All right. And the while loop, the way the while loop is set up, and what I'll do, I'll create one. And if you look at it, a while loop, the contents of a while loop is only executed if what? If this statement holds true. if this statement never holds true, then you're what doesn't hold true, you'll never execute these lines of statements. All right. Give an example. Let's get into here. Okay, so let's go. Let's remove this stuff here. All right. So say we do something like int x equals 5. Oh, well, not say 5. I'll say x is 0. X is 0. Okay. Then I'll say while I'll just do 3. While x is less than 3, and this is my body. What do I want to do if x is less than 3? I might say cout, because I'm just entering cost. We're not gonna save it or nothing. We just gonna say enter cost. But I'm gonna have to create a variable. So enter cost. Yeah. All right, so I'm gonna have to do all right, float them out. All right. So, and I'll leave it at this. So now I have a loop. There's a problem with this loop, but we'll look at it. Let's look at this logic. We setting the x equal to 0. Okay. Float, we're making it, amount, we're making it float. So this says while x is less than 3. So if x is less than 3, we want to do what's in here. Is x less than 3? Yes, it is. 0 is less than 3. So we fall into here. We're gonna prompt in a cost, and then we're gonna wait for an amount to be entered. But what we need to do is get to the end of the body. We come back to this while loop. When we get back here, x is what? X is what? Once we print this out and we return back to this while, what is the value of x? Anybody?
0.
X is 0. Print this out, come back here. What's the value of x? What's the value of x? Once we print this out, we get back here. What's the value of x? Anybody?
Until you increment it.
I can't hear you.
It stays 0 until you add something that'll increment it.
Right. So what happens is we're in an infinite loop. The program will get stuck at this point because what? X will always be what? 0. We never manipulated x to do anything to advance to get to 3. So we do a x or whatever we need to do, x plus plus, correct? So now the first time through, x is 0, we increment by 1, x is 1, all right? We increment by 1, x is 2, we increment by 1, x is 3. Is 3 less than 3?
No.
No, so it kicks on out and then continues on with the program. All right. So what? And if you take it like this, with that loop, I have a starting point. All right. My starting point is where x is 0. All right. We have a test condition. Right? To test to see if x is less than 3. But then we have our increment or decrement, all right, where we actually are manipulating x. All right, so we manipulate x, whether we add to it or subtracting from it to get to our destination of less than 3. Because we could have switched this around and said X was 10, right? And then we could have said, well, X is greater than 3, right? So all of a sudden now, if X is 10, it'll go, well, let's see, no, not 10, not 10, not 10, not 10. Right. Well, right. If X is greater than 3, X is greater than 10 is greater than 3, but if I keep adding, I'm gonna stay greater. So what I need to do here, this time I need to what? Minus minus. So I can what? Get down to here where X, well, what? 3 is not greater than 3, so it'll kick out. So it'll go 10, then 9, then 8, then 7, then 6, then 5, then 4, and then 3. Oh, kick out. So you understand? It just depends on how you write your logic, all right? You know, how you word your logic or whatnot. And you better believe it, you know, different people think different ways. Accomplish the same goal, but they may think in a different manner. And also I would say this, many times you have hackers, and what hackers may do, they may write code in a fashion that is, how would I say, the non-traditional way of thinking, so that it'll make it harder for people to just go in and look at it and see what they're doing. All right. So stuff like that happens. All right. So, but we have a starting point, X starting at 0. We have a test condition. We're trying to get X to at least reach 3 to be if it's greater than 3. And then we manipulate X. It's 0 and we're incrementing it, trying to get to 3. Starting at 0, trying to get to 3. So that pretty much your while loop. All right. So while this, all right, while X is greater than 3, and I gotta change this back. While X is less than 3, all right, do this and then increment. So let's run this program. All right. So if we run this, and all we're doing is entering amounts, we're not manipulating it or doing anything. In our amount, I'll say 10.2.28. Another amount, 2 point whatever. Another amount, and it should kick out. All right. So that's all that was. We was allowed to input 3 values. That's all this loop allowed us to do. Now, if we were to do a for loop to do the exact same thing this did, okay? Now, with a for loop, you know, okay, I want to go from 0 to 3, 0 to 3. So I could do something like this: for int X equals 0, X less than 3, X plus plus. Now, I want to show you something. If you look at it, int X equals 0. Look at this. Int X equals 0. All right. X less semicolon, well, X less than 3. X less than 3. X plus plus. X plus plus. So if you notice, I have all of the different components that I had in the while loop, right? This is my while beginning point. This is my for beginning point. It has everything set in it. And if I want to do the exact same thing, I could just copy this and paste it here. So I have 2 loops that are doing what? The exact same thing. So if I do this, I could do something like while loop. Okay. I just put a slash T here. And then I'll copy this C out here. And this will be the for loop. And I should say lowercase. All right. So if I execute these, they're both doing exactly the same thing. So let's run them. All right. Debug it. Okay. The while loop. And okay. The for loop. Wow, wait a minute. Something happened. Why did it do only 2? For x equals 0. Oh, what did I do, class? Who could tell me? Who could tell me what I did wrong in the for loop? Why it didn't perform the exact same way the while loop did? Anybody? It's because I'm manipulating it in 2 different places. See here? The x plus plus is already with the for loop. So I don't need to have it here. So that made it what? The first time through x is 0. It printed this. It incremented by 1, that made it 1. Incremented here, it made it 2. It performed this. All right, incremented made it 3. Incremented made it 4. 4 less than 3, no. So that's why I did it only twice. So you understand? I copied this, but this should not be here because it's already in the for loop up here where you got the starting point, the condition, and then how you manipulate it. All right, so let's run it again. Okay. And let's see what we get. And I'll put 1.1, 2.2, 3.3, 4.4, 5.5, 6, 8. Well, all right. So you see, now they both perform the exact same way. All right. So I had an issue where I had the plus plus. I was incrementing it twice. All right. I was incrementing it in 2 different places. All right. So I'll close that out. So that's the for loop. Let's go back to well, I'll show you the last one, and then we'll go back to the notes. The last one is the do until, all right, or the do while. All right. Now with the do will actually perform the statement at least one time and then check to see if it needs to be performed again. All right. So do, all right. So we say do, all right. What do we want to do? We need to perform this information here, all right. We need to perform this. I'm gonna copy it and I'll paste it here. So we need to do this. Now, once we do that, all right, we don't have nothing specified. So here we need to do what? X is equal to 0. That's our starting point, all right? So we starting with x equal to 0. But it does not have to have a value because it'll automatically perform it no matter what. And then we need to do our while. So this would be while x is less than 3, all right? And you always put the semicolon at the end of a do while. You have to. You don't do it on the while loop, but you will on the do, you put it at the end, all right, of the while. All right. So now I also need to do the x plus plus. So what? I can increment. All right. So first time through, increment is 1, then 2. Yeah, it should work. Right. It should work. All right. So let's run this, and then we'll go to the notes and look at what they talk about the format of all of it. So when we run it, this one, 3 times. And this is the next one. Oh no, it did it once. What happened? X is 0. Hold up. what did I do here? What did I do in here? All right. This is the do loop. I'll just copy this. Copy this, put this here, the do loop. All right. So, what did I got? Greater than? Oh, I got greater than. Where did that come from? Oh, I put greater than. All right. While x less than 3. I don't know where they greater than came from. All right, so let's debug it. All right, so we whatever. Oh man, that's wrong. Let me run this over. All right. Okay, here we go. All right, the loop. All right, and I left it as 4. It should have been the do. All right, so you see, and when I hit enter, it should end. So you see what happened? Each one of them performed 3 times, 3 times, 3 times. All right, so all 3 are loops. All right, and all 3 will allow you to perform something for 3 iterations. But depending on what you're doing, you need to choose which one may work best for you. All right, so let's go back to the notes. Okay, go back to the notes. So we looked at the while loop. All right. So it tells us, in a sense, the while where you had x less a number less than 5, that's your condition, checking to see if this value is less. As long as this value is less than 5, we're going to perform these statements. All right. Print out hello, and then what? Increment. Go back, check again. All right, so that's how your while loop works. And this is just an example. While number is less than 5, outside it had to be a number that was less than 5 in order for it to fall in here. All right, so whatever number it started out with, I don't know what it started out with 0. So when it started out with 0, 0, increment by 1, 1, increment by 1, 2, increment by 2, 3, increment by 1, 4. And then increment by 1, 5. 5 is not less than 5. So it performed this loop 5 times. All right. And this is just showing you the code and how it does. And this is just a flow chart. If x or while number less than 5, do this, go back and check. Okay, it's less than, do this, go back and check. When it's false, then it's just going to continue with the program. So the while loop is a pre-test loop. What that means is, in order for me to execute what's in its body, I have to test to make sure that the condition is true before it performs it. All right, that's all that means. It's a pre-test loop. You have to know what number is to compare it against 5, and if it is true, then it'll perform it. Otherwise, it will never perform it. All right. So that's what the pretest means. All right. So the while loop is known as a pretest loop, which means that the test, it tests its expression before each iteration. All right. And notice that the variable definition in line 7. All right. Where line 7 was where? Where was line 7? Int number is equal to 0. Number equal to 0. So it started out with being 0. And then 0 less than whatever until it goes on. So what happens if I change this to 6, int number equal to 6, while number less than 5, 6 is not less than 5, so it'll never perform that. It'll continue on with the program. We talked about infinite loops. An infinite loop is just a loop that a loop that's been defined to where you'll never reach the end. So if I say while x is equal to 0, while x I'll say is and I'll say greater than -1. 0 is greater than -1. If I increment it, 1 is greater than -1. 2, greater than -1. 3 is greater than. So I will stay in that loop. I'll never get out of that loop, and I'll show you. Okay, and I'm in the while loop, right? So if I keep typing 1, notice what happens. I'm stuck in that loop because what? My increments will never be less than -1. See, never be greater. It's always greater than -1. All right. So I'm saying while what is x is greater than -1, to keep entering in a number, keep entering a number. So it's going to continue to do that forever. All right. So that means what? I'm stuck in a loop. And programming, you as new programmers, you will run into that issue where you done found yourself stuck in an infinite loop. Best thing to do, check your conditions. What is the starting point? What's your condition? And what the increment? And a lot of times we may misinterpret this: greater than is less than is greater than, or something like that. So you got to make sure you go through your program and know what's going on in each step, right? So you got to watch that. All right. So I'm gonna just go and put this back less than 3. All right. So less than 3. Now, back in the program. So it just tells us in all but rare cases, loops must contain within themselves a way to terminate. Right? It has to be a way to make it continue on with the program. This means that something inside the loop must eventually make the test expression false so that it can what? Get to the end of the loop or execute the remainder of the program. All right. Then it tells us the loop in the 5.3, program 5.3 stops when the expression number less than 5 is false. But when we change number here to 6, that kept us in an infinite loop. All right. So, but as long as we starting at a lower number, it's gonna fall into that loop, and then until it gets to 5, if we increment. This is an infinite loop because we're never doing what to number. We're never incrementing number. We set the starting value. We have our test condition, but inside of here, we never incrementing number. No, number is never being incremented to get to 5. So it just keep printing out hello. All right. So once you add this statement here, plus, the first time, okay, 0, add 1 is 1, and 1 is 2, and 1 is 3, and 1 is 4, and 1 is 5, kick out. All right, so be aware of that, be mindful. All right. Don't forget the braces with a block of statements. Remember, I told you I always put the braces, whether when I do a while, or if, or for, or whatnot, I always put the curly braces because you never know when you have to go back and modify your code and you forget to put the curly braces, and now your logic is just all thrown off. But like I say, that's just programmer style. You don't have to. If you just got one line to execute, you don't have to put it in curly braces. But I just do it just to make sure I don't forget something. All right. Because look what happens here. This is an infinite loop. If we look at this, int number equal 0, and then while number less than 5, by default, it's going to do the very next statement for the whole body. And it will not leave until x is number is equal to or greater than 5. All right, give an example. Let's go here. So we have I have 2 statements. I want to have 1. I'll just do the C out. Okay, I'll do the hello like they did. I'll just see out hello. All right. So I'll do see out hello, and I'll take this out. So now, and take this out. Well, if I run it this way, it's not infinite. But if I do this, all of a sudden now, no matter how I have it spaced out or whatever, this for loop, this line here will execute every time. It's associated with that while. So when I debug it, See what I'm saying? It's going to continue to print out hello because all I just said was while x is less than 3, it started at 0, so it did fall in the loop, but the loop starts at this point and ends at this point. It never can do this until it falls out of that. So that's why I say, just always just for precautionary purposes, always put your curly braces. All right. It does not hurt. All right. It does not hurt. All right. So now this will allow it to output this, then increment. Check again, output this, increment. So when I do this time, what happened? Let's just debug, run it. All right. So look, the while loop, hello, hello, hello. The for loop is waiting for 3 inputs, and the do loop is waiting for 3 inputs. So you understand? So like I say, just make sure that I'll say use the curly braces. But you don't have to. If you can understand what's going on, why, hey, power to you. You don't have to. All right. And like I say, it's just programming style. Now, this is kind of confusing, but will it work? Yes, it will. All right. And what they're saying is this very same statement here. I can't have this comment here, but I could take all of this and put all on one line. All right. I didn't have to space. Put all this on one line. All right. I don't have to space. Take out this comment here. Because you can, when the comment gonna start from where it first began. What did I do? All right. And then take this and put it. That's valid. You understand? So I just took that while loop and put everything on one line. The only issue with that is if you have an error, this is the line that error is on. So you may not know if it's this, if it's this, if it's a curly brace, or if it's this. So that's the only downsize to that. But if it's working, it's working. You know what I'm saying? It will work. Let's run it. And you're going to get the exact same output. See what I'm saying? Exact same output. All right. So it will work. All right. But it'll make it more complicated or more harder to debug. All right. Make it more harder to debug. But like I say, your programming style, if that's what you choose, I'm not mad at you. All right. All right. We did the while loop. Now, using the while loop for validation. Now, what happens is you can make someone stay within the while loop until a value is given. All right. So what happens is, if you look at this say while number is less than 1 or greater than 100. Print out error this, that. So all of a sudden now they're gonna be stuck in a loop until what? They give you what you asked for. So it's kind of like this one. I could say, what was I here? I'm gonna take this back off. All right. So now I could I'm gonna go further. All right. So what I could do here in this while loop, I could say, all right, please enter a number from 1 to 100. Now, what I'm gonna do, I'm gonna change this to int. All right. Now, so now, so this says while, let's say while it's less than 3. So I can't do this. I only can enter negative numbers or a number, any number less than 3, right? But this is not what my prompt say. My prompt say what? In a number from 1 to 100. So I have to change this and say something like I could set amount equal to, I have to give it a value, all right? I'll say give it 1, all right? So I'll give it a 1, just to what? Fall in the loop. Then I could say, wow, amount, like they had, less than 1, or, not that, or amount greater than 100. So what that's saying, if it's outside of the, if it's less than 1, anything going 0 to negative, or greater than 100, anything 101 and above. Oh, wait a minute. I need to put this up here. I need to move this up. All right. So I can know. All right. So now, so if that amount is less than or whatever, now I could tell them, all right. All right, so look, please enter a number from 1 to 100. Now, what'll happen is it'll keep, if I enter, as long as I enter a bad number, it'll stay on that. All right. So when I run it, all right. All right, say I enter 101. Whoa. Let's see what's going on here. Oh, what I didn't do, I didn't prompt again for the number. Seeing all right, I didn't prompt for the amount, all right, because it just stayed with the same number. All right, so now enter amount 101. All right, so look, please enter whatever 101. Please enter 101 555. So, and then if I put negative 33, you understand? So it's gonna keep prompting me until it's gonna force me to input a valid number 1 through 100 before the program continues. So now if I put in just 33, bam, now my program moved on. So you see what happened? It allowed me to just stay there. And not give me a right value. Now, is the value 33 a correct value? Class, you still never know if a person input a number that they're supposed to put in, but at least you can validate the numbers that are put in. And give you an example. If I had some software, or I've written some software to input your test scores, all right? So I'll give you a handwritten test to do. I grade the test, and I put in the test scores. And I write my code that says, please enter a number from 1 to 100. Now, what happens when I type in a test score of 105 mistakenly, right? It's going to tell me that please enter a number from 1 to 100. But say you made a 99 on the test, I could still put in an incorrect value. I could put in 88, which is valid in the range, but not the actual score that you made on the test. So all I'm telling you is the validation is only making sure that the numbers or the input that you're putting in is valid as to the criteria for writing the code. But to say, oh, I wrote this program and I know that all the data input is correct, no, you don't. Because like I say, it's up to that person who's doing the input of that data to make sure that they are inputting the data in correctly. All right. Hopefully you can understand that. Because and many times, and like I say, I wouldn't tell you to book the system all the time. But if you know for a fact something is something, uh, don't take for granted that whatever output or whatever a computer spews out is 100% true. All right, you go to pay, go to pay your bill. My bill is whatever. Oh, well, this is what we have. That doesn't necessarily mean someone did not make a mistake. That doesn't mean somehow uh, the program had some kind of error in it. But they write the code so that it can limit the data so you can get it as true as possible. All right. That's all I'm saying on that. All right. Okay. So now, so like I said again, it check to see if something is valid or invalid. If it's valid, all right, or if it's invalid, it's going back, displaying the error message, reading again, display the error message, reading again, display the error message, checking again, checking and checking till they input something good, and then it goes through, which what we did. All right. So looking at this program, the program calculates the number of soccer teams of the youth league may create from the number of available teams. Okay. So you input the data. All right. So int players and team num team left over. So what happens here? While team players is less than minimum, all right, and team players is greater than maximum. So if you got minimum or you got over the minimum, under the minimum, or over the maximum, oh, there's an error. All right. You should have at least so many players on the team. So all they're doing is just giving you another life scenario as to how you can write code, dealing with the while loop. Okay. Again, here, while players is less than or equal to 0. How can you have a team and you don't have any players? Right? That's some type of error, right? Some type of problem. All right. So here, leftover players modulus the team players. All right. So if you got a certain number of team players, taking the players minus team, modulus the team player to give you how many left over. All right. So if I have 10 players on the, if I have 50 players and I got 10 team players, so I do the 50 modulus 10, I'll have 0 left over. That means each team has 10 players. All right, 5 teams. I'd have 5 teams. All right, with no leftover. All right. So those are some of the things that this program does. Counters. We kind of dealt with counters to where num was a counter that would increment. All right, num is what's going to increment, and we use x. X was our increment or our counter. As we go through the program, it will actually increment and determine whether it's greater than max number. All right, so that's all that's showing. The do while, and it tells us the do while loop is a post test. So you perform the statements and then you test to see if your criteria is true or false. All right. So the data or the information will be read at least one time. Many times programmers will use the do while for menu driven systems because what? You want to list the menu first, and then based on the choices from that menu, you may branch out somewhere else. Or if they input an invalid value, then they go back and maybe list the menu again, or either prompt please and or whatever. But you do want to list the menu regardless. All right. So the do while it works good when you want that code to be executed regardless of the situation. That first time, and then after that, check to see if you want to execute it again. So it tells us the do while loop looks something like an inverted while loop. Whereas the do while loop loops format when the body of the loop contains only a single character. I mean, a single statement. All right. So let's say here. Now, look, this format, same thing, but I would use the curly braces just for precautionary purposes. I'll just use it. All right. But like I say, and this is a single statement, but I'll just use it just in case. Notice how they got the curly brace when they got what? Two or more statements. But I'll use it whether I have one or two. Because what happens when you start adding to your program and then you add that statement and it's like you execute it. Oh, I got it. I ain't got no errors. But then you happen to execute it and you get to that point and it's like, man, that's not the right output. And now you're trying to figure out where and what did you do. And simply what? Curly braces was not put in because you have two or more statements, right? But like I said, you don't have to put them, but it's just a programmer's preference, all right? But I would put them just in case. So it says the while loop, the do while loop is a post test loop. All right, this means that it does not test the expression until it has completed at least one iteration. As a result, the do while loop always performs at least one iteration, even if the expression is false to begin with, because it's not checking till what? The very end. This differs from the behavior of the while loop, which you will recall is a pre-test loop where it is tested before it actually falls into the loop. Okay, so that's all it's saying. This program will test to see if X is less than 0 before it perform this. Okay, it's 1, it won't perform it, it's going to continue. This, the do while loop, X is 1, but regardless of X is 1, 100, 55, whatever, it's going to perform this. Then it's going to check to see if X is less than 0 and whether to determine whether or not to go back and execute that statement again. All right. So that's all it's saying. It performs the statements, then check the expression. If it's true, then it performs it a second time. If it's true, a third time. All right. But if it's false, can kick out. And even though if you come in executing the first time, if it's false, it's still going to execute it. Oh, false, oh, continue. All right. So it's going to execute those statements at least one time. All right. All right. Now it tells us you should use a do while loop when you want to make sure the loop executes at least once. Like I say, like normally with a menu. All right. For example, in this in program 5.7, averages of a series of 3 test scores for a student. All right. So what? After the average is displayed, then it asks the user if he or she wants to average another set of test scores. So what happens? I'm going to execute an average program. It's going to automatically ask me to input my value because I said I wanted to execute an average program. It didn't execute an average program and then have to have a value set in order to fall inside a while loop, then perform it. No, I'm going to perform it one time, and then I'm going to ask them if they want me to do it again. So if you look here, I have all my variables declared. Again is my choice whether or not I want to execute or perform another calculate another average. So okay, what I'm gonna do the first time through, I'm gonna prompt enter 3 averages. And they're gonna say whether you enter them all at one time or by space or 1 enter 2 enter 3 enter. Either way, it's gonna accept them. Then it calculates the average, tell you what your average. Then it's gonna prompt, do you want to average another set? Yes or no. All right. So if you put a capital Y or lowercase y, it continues. Now in this one, it doesn't validate whether you put Y or not. Because if you put an A, it's gonna just kick out. Because what? Do again is not equal to Y. It only gonna come back here is if you put a what? A Y or capital Y or lowercase y. But you can't control that with a loop where you can tell it do okay while well, down here, well, up here, like say, if it's not equal to y, please enter y to continue, please enter n to exit. All right, like that. Now, so this just showing you your output the first time through that three numbers, hit enter, aid it. Type Y, three numbers, enter, and the 74.33 in, you exit it. But you could have put any letter, but it said while in, and you exit it. All right. Using do while, okay, with menus. Okay, and remember we had this menu with the adult, whatever. But now what they did, your menu, you want the menu to display. So you don't want to set a condition to where it falls in. Normally a menu, you want to execute it regardless. So do this, okay? Display one, standard adult, two, child membership, three, senior citizen membership, four, quit the program, and then enter your choice. And then whatever choice you enter, then you're going to continue on. But then here, while choice is less than adult choice or choice greater than quit. So if it's less than one or greater than four, we're gonna just allow, please enter a valid choice. Please enter a valid choice. So here, see, that's why, like I was telling you before, a valid choice. It's gonna do this, but it's gonna make sure that this is done. Now, the do while ends down, where the do while ends? The do while really ends down here, right? But then I have this while in here, which actually gonna loop until they give me the right choice, whether it's a 1, 2, 3, or 4. Anything outside of that, I'll keep getting please enter a valid choice. Okay? All right. Now, the for loop, right? The for loop normally works well when you know how many iterations that you want to perform. Like say, if you say, well, I know I have 10 students and I want to be able to input my, well, say not 10 students. I have the 3 grades that I want to input. And you're going to say, okay, I'll make that loop iterate 3 times. Right? Or if I have 10 amounts I want to put in, I'll write it through where that loop iterates 10 times. All right. So the for loop is ideal for performing a known number of iterations. Like I said, if you know I want to perform something 100 times, go from 0 less than 100. All right. And increment, keep increment. All right. In general, there are 2 categories of loop: conditional loops and count control loops. Okay. A conditional loop execute as long as a particular condition exists. For example, in an input validation loop, all right, so what? I input Y. As long as I input Y, it's no determined, what? You don't know how many times your person gonna input Y. They can enter 5, 4, 1, 100, or whatever. All right, that's a conditional loop. All right, but then you have the other loop, okay, where the count control, all right, you know the exact number of iterations that you want that loop to perform. So that's where it actually counts, going from 0 to whatever, and you know how many times it's gonna iterate. All right. For example, if you ask a user to enter the sales amount for each month of the year, so what? We know that loop should iterate how many times? 12 times. We got 12 months in a year. It should iterate 12 times for the 12 value. All right. In essence, the loop count to 12 and asks the user to enter a sales amount each time it makes a count. All right. So the count control loop must possess 3 elements. All right. And that's like what I showed you with the do and the while and the for. All right. The initial starting point. All right. The starting value. All right. Then your test condition. All right. So then what you're comparing it to. Is it greater than this? Is it less than this? And whatever. And then whether or not to update it, whether you're going to increment it by adding it or you're going to decrement it by deleting from it. All right. So those are the 3 things which I showed you in the code when we first wrote it, like with the for loop, your starting point. All right, that's the starting point, your test condition, and then your increment. All right, the while loop. Oh well, this one changed, so that's not really one. This one is a conditional one. So as long as I put in long as I don't put in a number between from 1 to 100, it can keep on looping. All right, so that's a conditional. This one is the counter, whereas you start at 0, the condition while it's less than 3, and then my increment. All right. So um, now, so that's basically it. So the for loop. This says for count is equal to 0, count less than 5, count plus plus. Starting at 0, stopping where a count is less than is not greater than or equal to 5. All right. So it will perform 5 times. It would output hello 5 times. All right. And basically, we went over that and showing you this semicolon, this semicolon, and then that. All right. Now, notice they don't have curly braces. It will perform this 5 times. You get hello, new line, 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 hello, new line. But I would put curly braces at the beginning and the end, just in case I have to modify my code. I can do so without having to worry about where my curly braces go. All right. The same thing here. It's going to perform what? 10 times. Now you say, well, why 10 times? Because it's starting at 1 and it's ending at 10. All right. Anything that's 10 or less is going to perform. Remember the last time we had equal less and less than. Now we had less than 10, then it will perform 9 times. But it's starting at 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it will perform 10 times. All right. So that's, you got to be mindful of that. Less than or equal to, greater than or equal to. Got to be mindful of that. So, and looking at this program, what this is a for loop. It asks you to, it give you a minimum number, all right, a maximum number. So minimum is 1, maximum is 10. So for num is n. For num is equal to minimum, all right, min number, all right. So num is equal to 1. Number less than or equal to max num is 10. So as long as number starting at 1 is less than or equal to 10, and that's the same exact thing we have right here. Same exact thing. While number is equal to 1, number less than or equal to 10. While number equal minimum value, minimum number, which is 1, number less than or equal to max number, which is 10. See? Num plus plus. So it's the exact same code written different. That's all it is. Exact same code. Now, here it shows you, give you an example. This is the expression, number equal min num. I'm setting it to equal to 1. Here, it checks, where it checks, evaluate the test expression to see if it's true. If 1 is less than or equal to 10, yes, it is. And then perform the update expression to go back, and then go back to the steps, all right, through the steps in the performance, all right? So that's all that happens. Assign a value and then perform this, check, perform, check, perform, check, perform. And it does that 10 times and then it kicks out. All right. Using the for loop instead of while or do while. All right. You should use the for loop instead of the while or do while. All right. In any situation that clearly requires an initialization. All right. Uses a false condition to stop the loop and requires that the update occurs at the end of each loop iteration, right? So that's why you should use a for loop, okay? For example, in talking about program 5.9, it requires that num variable be initialized to 1. It stops at a certain number, which was 10, and it is to be incremented each time you go through the loop. All right. So, like I say, you'll be able to determine which loop would be advantageous for you to use at different times. All right. So, all right. And then you could take a for loop and break it up into a while. Okay. This is my declaration where I'm initializing my num to be equal to 1. This is my test condition, num less than equal to max number. And this is my expression where I keep updating my value to go through the loop X number of times. All right. So you can break up a for loop and use it and create a while. All right. Now, a for loop is a pretest condition. All right, because the for loop tests the test is test expression before performing it. So it has to test it. And I'll give you an example of what it is. So look here. In this one, I got int x equals 0. All right. Then it's going to test it. If x is less than 0, or if 0 is less than 3, then it performs it. Because I could put x is equal to 10. Then it will not what? It will not perform that particular. It's going to go just straight to the do. So let's run it. So it is a test. So see here, I'll put in 44. Wait, why did it went to the for loop? For loop. Why did it go to the for? For x is equal to 10, x less than 3. And why did it do that? Let me see. Debug it. Okay, I got an error. No, okay, let's do that. Well, this said nothing. Okay. All right, let's see. It didn't run. Let's see, run it. Run it. I'll put in 55. See? So it skipped the for loop because what? X was equal to 10, and 10 is not less than 3, so it tested it here, and it was not less, so it skipped that loop, and then it went to the do loop, all right? Do while, all right? So that's all that happened, all right? So it is a test, all right? Now, okay. Avoid modifying the counter variable in the body of the for loop. Yeah, remember I did that the very first time when I did no, that was in another class. But if I add a for loop here, really I'm adding what? I'm adding 2 because it's gonna add here and it's gonna add here. So give an example. This is going from 1 to less than equal to 10. So x is 1 less than equal to 10? Yes. Okay, see out 1. Okay, it's gonna see out the number 1. Then it's gonna say 1, add 1 to 1, that becomes 2. Add another 1 to 1, that becomes 3. So I'm gonna output 3. Then I'm gonna increment 3 and get 4. I'm gonna increment 4 and get 5. Is 5 less than 10? Yes. So it's gonna print out 5. It's gonna increment 5 to 6. It's gonna increment 6 to 7. Is 7 less than 10? Yes. Okay, it's gonna output 7, and then it's gonna increment 7 to 8, and then increment 8 to 9, and then it's gonna output 9, increment by 1, and then now it becomes 10. I mean, I got lost track. It printed out 9, increment 1, but it's 10, add 1 to 10, 11, and it kicks out. All right. So what it is, you're doubling the increments of x. All right. Starting at 1. Now, if you started at 0, it went 2, 4, 6, 8. But being that we started at 1, it was 1, 3, 5, 7, 9. All right. So, other forms of the update. So look what happened here. For I keep saying x. For num equal 2, num less than equal to 100, num plus equal 2. So what we doing at this point? We increment by what? By 2, right? So now we incrementing, we going from 2 to 100. I mean, we going from 2 to 100, counting by 2, all right? So what happens is a number is equal to 2. Is 2 less than or equal to 100? Yes. Okay. See out 2. Then you increment 2 plus 2, you get 4. Is 4 less than 100? Yes. I'll put 4, come back again. 4 plus 2 is 6. So see what's happening? We jump in a number, right? Also, we can do minus minus. We don't have to always add. We can take away. We can subtract, all right? So for num equal 10, num greater than or equal to 0, num minus minus. So now all of a sudden we go in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. Because we're saying what? Less than or equal to. You got to remember that. You're not just going to 1, you're going to 0. All right. So that's how that works. And it's saying defining a variable for a for loop loop's initialization expression. So what they did was they had a variable here that was declared, remember, as 1, and then a variable here that was declared as 10. All right. So you can do that in your program. You don't have to just use a constant value where x equals 0, x less than 10, x plus plus. No, you can use a variable. You can even take another variable. Like say if you had y equal 3, you could say, well, int num equals min num less than y, and then num plus plus. So any variable that you have can be valid to use as an inner value to use in your for loop. All right. So it says, okay, when a variable is defined in the initialization expression of a for loop, the scope of the variable is limited to the loop. All right. Now, what that means is this. See this int count? Count is only known inside the for loop. And then what happens here, this will be an error, what they're talking about. Let me show you why. If I do for int x equals, all right, and what I'm gonna do, I'm gonna change this x to y equals 0. So that means this y be 0. Now the reason I did that and y plus plus. Now this is for the do while, okay, Clint? All right. So now, notice what happened. The only place I have x, where's x? X here, in this for loop. So in this for loop, I introduce x. Int x equals 0, x less than 3, x plus plus. That's the only place I'm referencing x. I had it here, but I changed it to y. In my while loop here, my while loop, I'm using amount to do something. In my do while loop, I'm using y. So I'm only using x in my for loop. So what that means is, being that I said int x in this for loop, x is only known within the scope of this for loop. Anywhere in here. If I come out here and say, okay, well, I'll just do something like int value is equal to x. Watch what happens. I'm gonna get an error on x. Why? Because the scope of x is only between these two curly braces. That's the scope of x. Because I introduced it here, I initialized it here. I could even initialize another value. I could say something like, I'll take that off. I could go in here and say int cost equal amount. Well, I can't do it that way. It might be an error. All right, but cost equal amount. And then I try to do something like this. Cost is only known in what? The scope of this for loop, because this is where I'm actually introducing it. All right. So it's only known inside the scope of that for loop. So you got to be careful when you do something like int x or int index or int max value equals whatever. It's only known in that scope. Now, can I have x outside the loop? Yes, I can. But that x is a different x as opposed to this x. All right. You got to remember that the scope of the value. Okay. The scope of the value. Now, okay. So just creating a user control loop. Now, what happened here is disallow you as a user to input a value and then use it within here. So look, what they did was they created this, but then they said cn min num, cn max num. So rather than this loop executing from 1 to 10, now you can do it from -5 to 25 or 4 to 8, whatever numbers you put in. But you have to make sure what? The min number is less than the max number in order for it to loop, all right? So now in writing it this way, now, like I said, if you had either some numbers you wanted to average or something you needed to do, you can say, okay, let me put in my loop how many times I wanted to iterate. And then that way you could put in the start value, the end value, and then let it work, do what you wanted to do, fall into that loop. All right. So what happens, you enter a min value, a max value, and then they enter 6, okay, and then they enter 12. So what happened, then 1, 2, 3, 4, 5, 6, 7, because it did it to less than or equal to, right? So it started with an 6 and less than or equal to 12. That's why you have 7 values. So then what it did took the first value, squared it. Next one squared. All right. So that's all they're showing you in that form. Now using multiple statements in initialization and update expression. All right. So all this saying, there's many different ways you can write loops. We're not going to write programs using all these different ways, but it's a good the good idea to look over them to see that you can use these different ways in writing code, so that when you do start writing code, you might need it, or you see other code, you won't be so confused as to saying, oh, what is this? I've never seen this before and whatnot. So if we look at this, we have X and Y, but this says for int X equal 1 and for Y equal 1. So I said X to a value and Y to a value, semicolon, and then I'm going to perform this until X is less than or equal to 5. Now, what's the scope of X and what's the scope of Y? This for loop, because no, scratch that. The scope is outside because they're declared at this point. All right. So the scope of these values are outside of you can use them in here, but you can also use them outside of the for loop. So what they did is see out X, which is the 1 at the first time, and then the word plus, and then Y, which is 1. All right. Then the output equals, and then what they did was the expression X plus Y, which is going to give you 2. All right. And then the next time through, Y stayed the same, but X incremented, and X becomes 2, and Y is still 1. And so 2 plus 1 is 3. All right. So you see what happened. And if you look down here, this is what happened. All right. 1 plus 1 equals 2. All right. Then the next time through, X is still less than 5. 2 plus 1, which is right here, plus the 1 equals, and then 2 plus 1 gives us 3, and on and on and on till it get to less than or equal to 5, which is the 6. All right. So no, less than or equal to 5, which is the 5. All right. So so that's how that works. But then look here. X equal 1, Y is equal 1. This is condition, X less than equal to 5. X plus plus, Y plus plus. So now you're incrementing both of them at the same time. That can be done. Our programs are not going to be written to do that or use that feature, but know that it can be used. All right, class? Know that it can be used. All right. Now, look here. You can omit an expression. All right. So all of a sudden, int num equal 1. You know what the starting point of num is. It's outside the scope. Is equal to 1. You don't have to repeat it. All right. You know it's equal to 1. Num less than max value. Num plus plus. Same exact thing. It's just that it's outside. It's understood, and they just didn't repeat it. All right. All right. So there's many different things you can do. All right, look here. All they're doing here is incrementing here rather than here. So all this is programmer style. What is your style? But look here though. Look what you have here. Semicolon, semicolon. All right, and you're outputting this. So you can either go as far as to omit all three. Really, like you're really not doing anything. All right. Be warned, however, that if you leave out the test expression, the loop has no built-in way of terminating. So what it is, you're in an infinite loop. Another thing I would tell you never to do, never put a semicolon at the end of a for loop, all right, or at the end of a while loop. What I mean by that is, now to do while you need it, all right, but say if I do this for whatever, and put semicolon, what I've just done is just made this my for loop, and then it's going to do this 3 times, this one line 3 times, and then it's going to ask me to input an amount and going to output the amount and going on and continue. So those are some of the things you got to watch out for, all right? You got to watch out for, all right? So, and even here, if I put a semicolon here, all of a sudden, it's going to just ask me to please enter amount, all right? Well, when I enter amount, whether I put a negative number in, it's going to skip that, all right? No matter what I put in, and it's going to say, please enter a number. Watch, I'm going to give you an example. None of my loops going to work, all right? So let's say, please enter a number. Well, let's see, let it come up. All right, so say I enter 33. Look what it say. Please enter a number from the range 1 to 100. That was for my what? Invalid. But what happened when I put a semicolon here, that says this is one statement. It ended. Now just continue on with your program. So now I'm going to input a number. It don't matter what number I input. I could put in negative 99. It's going to continue because my while loop is gone. All right. Now my for loop, what done happen here is I done perform this 3 times, and now it's just going to allow me to perform this, which is going to be 1 time, and continue with the next loop. So I'll put in a value, and see, it went on to the next one, and then I'm finished. All right. So, and what it did was with the sin. I don't know why I hit it. Whatever. Y is equal to 0. Yeah. I'm not understanding why this happened. Yeah. Well, let me run it again. But that's what happens when you put that semicolon in there, class. All right. I'll put in a valid number. It's still saying it's invalid. Put in an invalid. It went on to the next one. Put in a cost. Then it asked me for a loop cost. There you go. All right, so see what happened? All right, then the last one worked because I didn't modify it, but this one I put a semicolon at the end of here and a semicolon at the end of here, and that's wrong. That's major wrong, major. Make your program run wrong. All right, won't give you any errors, but your program logic has just changed. All right. So keeping a running total. What happens with keeping a running total? All that says is I'm keeping track of all my variables and the values as I'll go through the program. Every line, what happened? When this variable changed, and what's the value of the other? When this variable changed, what's the value of the other? So you keeping track of what's going on in the program. All right. And I'm backward. They're talking about a running total. A running total is a total that would be accumulated. I could write a loop that assigns a value to a variable. All right. And I'm gonna give you that example. All right. I'm gonna take all of this. I'll keep the for loop. All right, I'll keep the for loop. All right, so I'll keep the for loop and I'll put them out here. I'll make it int. All right. All right, so I have our amount. So I'll read it in, and then I could say total. I'll say amount and total. All right. So inside of here, I could read in the amount and I could say total is equal to amount. All right. Now, and then after that, I could output total. Okay. All right. So if I run this program, all right. So I enter 5, 5, and 5. But my total is not 5. My total should be what? 15. What I did was, rather than accumulate a total or get a running total, every time I read in amount, I just stored it into total. Read in the next amount, stored it in the total. So each time I just overwrote the previous value, okay? So I didn't get a running total, all right? In order for you to get a running total, you have to add what's on the left side to the right side, okay? How's that done? So I'd have to have total is equal to total plus amount. So now, and then up here, and I have to have total is equal to 0. Because if it's on the left side, it don't have a determinate amount. So the first time through, if I input 5, 0 is equal to 0 plus 5. And it's going to store 5. Then it goes through the next time. If I put 5, 5 is equal to 5 plus 5. That gives you 10, and then overwrite 5 with 10. Go through the next time. 10 is equal to 10 plus 5. 10 plus 5 is 15. Then it overwrites 10 with 15. So if I run this, all right, this time when I put 5, okay, right, 5, 5, and 5, notice what happened. That's a running total because I used it, the variable on both sides of the equal sign. Now we know there's a shortcut where I could have did just this plus equal. Same difference, right? Total is equal to total plus amount. So when I run this, all right, when I debug it, give it the same values, and it give me the 15, right? So that's how you get that running total, by adding to both sides. You got to add this variable to both sides of the equation. Well, I ain't to add to both sides, but it's on this side, but you got to add it to this side of the equation, and then it'll overwrite what's in that. Okay? So in the book, it shows us that down here, and it's the same thing. That running total, look, total plus equal sales. So each time this for loop is executed for X number of days, whatever sales value they input is being added to total. If I add 5, it's added to total. If I add 3, it's added to total. As I keep putting in the values, keep adding to that total. All right. So that's how you get that running total. A sentinel value. A sentinel value is a a special value that marks the end of a list or a value. All right, a value. So what I could do, I could say, okay, while, and let's do it. I could say while input, and I would say input, while num not equal to 999. All right. So what happens? All right. I could do something like this. I could leave amount and totals, and I'll say num equal 0. All right. All right. Int num equals 0. All right. So I'll say int num is equal to 0. Remember my starting point or my beginning initial value, my test condition. So what? I'm going to perform this loop what? Until this is equal to 999. So now I need to go down here and say, all right. So when I run it, okay, I think I got everything correct. I'm gonna run this program. How many times it gonna run? It's undetermined. I put in 3. All right. Put in 9. All right. Put in whatever. Put in that. I put in 999. Uh-oh. Why? Did I do the CN? Let me see that. Did I do the CN? No, that's right. That's right. I do CN num. That's what I didn't do. I didn't do the CN because so it's gonna always do that. So before I go back to check, I need the input num. So that was my fault. So let's look at it. Okay, put in a number. Okay. Type 999 to exit. I'm gonna just put in a number. CN num. Cell type 99 CN. As long as it's not equal to 999, if num equal 9, no. Why it's not getting a number? Why it's not getting a number? Seeing them out. Seeing them out, seeing number. Let me see what's going on here. Debug it. Okay, in our cost, okay, I'll put in a number. All right. Type 999 to 8. Right. So I'm not gonna type 99, I'm gonna put in a number. Right. I must have put in a character. So now in another cost, I'll put 300. Okay. Type 999 to exit. I'll put in 53. In our cost. All right. I'll put in 400. So see, as long as I don't put 999, I'll put in 999 here. See, and that's my total. That's a sentinel value. All right. So it's looking for a particular value to end the list of whatever. All right. You can even do it on a read while such and such not equal to whatever, dash, or whatever. Sentinel value. All right. So that's what they are. Now, what time it is? Okay, let me try to wrap this up. I know you have to go. Sentinel value. So look here. Point not equal -1. So you do whatever you got to do. But as soon as they put in a -1, then it'll exit out. All right. So I'm gonna do this while it's not equal to -1. Do that. As long as when it's -1, then I'm kicking out, they're gonna add up the games or whatever. All right. All right. Focus on software engineering, deciding which loop. And like I say, class, you got to be able to do your research, got to be able to plan it. You got to be able to even do your documentation or whatever so that you can have something to fall back on to know what it is you're doing and what you might need to redo or whatnot. All right. And like I said, deciding on what loop. Although most repetitive algorithms can be written with any of the three type loops, each one works best in different situations. All right. So it just tell you the while loop is a conditional loop, which means that it repeats as long as a particular condition exists. And it is a pretest loop. So it is ideal for situations where you do not want the loop to iterate if the condition does not hold true. All right. Then it tells you about the do while loop. You may want information to be displayed or executed at least once before it's tested because it is a post-test loop. All right. And like it's ideal for menus or whatever, stuff like that. Then you got the for loop, which is ideal if you know how many times you need to iterate that loop. All right. Now, then you have nested loops. Nested loops are loops within loops. And if you look at this, for minutes equals 0, minutes less than 60, for int seconds equals 0, second less than 60. So what happens? When this is 0, it falls into this and goes 0 to 60. It falls out, minutes here become 1. Falls into here, 0 to 60. So what happens? It's going to perform this 60 times and this 60 times. All right. So what happens is the first time, 60. The second time, 60. The third time, 60. The fourth time, 60. So each one of these 60 times is going to perform 60 times of this. All right. Give you an example. If I have a loop, a nested loop, if I have something like all right. Oh yeah. And then I have this one, and I know I'm like I told you I like the curly braces. I'll just say 4. All right, 0. Class, how many times you think it's gonna print out hello? How many times you think it'll print out hello? Anybody? This 5, 4. Every 5 is gonna print 4 times. So 5 times, well, 0 to 5 is 5. 0 to 4 is 4. Or less than 4 is 4. 0 to less than 5 is 5. So 5, 4 times is what? 20. So if I run this, and it should run, the total, don't worry about that. So what? 1, 2, 3, 4. If I could, let me stretch this. All right. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So what? 4, 8, 12, 16, 20. So what? When this is 0, 4, 1, these 4, 2, these 4, 3, these 4, 4, these 4. So you see what happened? A loop within a loop, the for loop is going to perform this iteration of that loop times this iteration. All right. So that's like 20 times. All right. So class, what I'll do, I'll post the assignment but I won't make them do because, like I say, I think we need to continue with the nested part. We just look at it. We're almost to the end. You know, that's the nested. But we'll look at file storage or whatever on next class period. All right. But what I'll do, I'll post the assignments if I haven't already done so for chapter 5. All right. No, not here. What happened? Come on. Why it's so slow? All right, so let's see something. Chapter 5. All right. So what I'll do, class, I'm gonna post the programs. Now, the programs, they all do the exact same thing, but you're using different loop, the 3 different loops to do them. All right, write a C++ plus program using the nested loop, choosing 2 of the 3 loops discussed in the chapter. All right. All right, a while, the while, the do, or the for. All right, allowing the user to enter to continue calculating the average of 3 numbers. All right, so please enter 3 scores, calculate the average. Do you want to calculate them again? Calculate another 3. Yes, and then 3 more numbers. That's what that assignment is. All right, so now let me kick this. Hello? Man, these people. All right. All right. So now that's the first one. The second one is basically the same. All right. Oh, wait a minute. No, these are input files. So yeah, I need to go over these 2. These are input files. All right. Where you're gonna have to read an input file and write data to the screen. And then the next one, they're gonna read an input file and write the data to an output file. I got videos on it and whatnot. You can go at them and whatever, but I want to go over that information also. But I'll post the assignment and I'll make them do 2 days after next class period. So once we meet next class period, you know, hopefully you have your questions so we can get together and do whatever, and then you have till that Wednesday or that Friday to complete it. All right. Well, that Thursday or that Friday to complete them. All right. So anybody with any questions?
I do, Mr.
Yes. Oh, yeah. And somebody else had a question. Yeah.
The student roll call sign-in for today.
Yeah, me too.
It's not operating.
What it
Yeah,
said?
can't sign the roll.
Yeah, it's just a
comes
blank
up as
screen.
a blank screen.
Oh, just a blank screen? Oh, yeah.
Yes, sir.
Let me see something. So you don't get to nothing, or you get to the point for the
Click
roll.
on signed roll and nothing's there.
Oh man, check something out. Yeah, sure is. I see it. All right, then yeah, I'm gonna have to check my code and stuff. Yeah, because they did change some. They updated their software. All right, yeah, I'm gonna have to check that. But go on and put your names in the chat and go ahead on and just put your names in the chat. Some of them been left already. But what I'll do, like I said, I'll post these assignments and then I'll finish up on next class period. All right. Anybody else with any questions? I know I need to deal with Mr. What? I forgot his name.
Law, Mr. Law.
Mr. Law, okay. Anybody else with questions? Hello? If not, like I say, I'm gonna post this. I'm gonna post this information, and so you can actually try to get started with your program. read up on loops and whatnot, and we'll discuss it on next class period. All right.
I had a question.
Yes, I'm listening.
I don't know if y'all may had said something earlier before I was able to get logged into the meeting, but on my test it had the HTML code 2 on one of my questions.
Yeah. Okay. Yeah. So I'm gonna have to look. You don't remember what question it was, huh?
If you give me 1 second, I can pull it up.
Yeah. Okay. I'll publish that. Save that. And then the last one.
On mine, it was question 48.
What was read the question? Read the.
The question was, which statement allows you to properly check the char variable code to determine whether it's equal to C and then output? This is a check and then advance to a new line.
Okay. All right. Okay. All right. I need to check that. Yeah. And yours was 48.
Yes, the question was 48 for mine.
And what's your name?
Ashley Moker.
Mocha. Yeah. All right. Okay then. Yeah, I'll be able to check that out, and depending, I'll give credit. Just like say, just give credit for that question, regardless.
Sounds good.
Yeah.
Thank you.
All right. Yeah. Anybody else? Hello? All right, Mr. Laws, what you got?
Would you like me to share my screen so I can pull the test up and you can look at it?
Yeah, okay. They still got people on though, but if you don't mind them looking at it, I know they still got people on.
All right, give me 1 second. I'm right now. I'm in the call on my tablet.
Hold up. Hold up. I could pull it up.
Okay.
Yeah, I can pull it up.
All right, give me 1 second. I'm gonna pull it up on my end.
Yeah. And that was test what?
Number 4.
Lord.
Mm-hmm.
And what is
number 42 was the one I was telling you about.
42. Where am I? 42. 42. Oh, yeah. Yeah. Oh, yeah. You don't even have an image to compare, nothing to do with it.
Yeah. I didn't know what to do on that one, so I figured
No. What I'm gonna do? Yeah. What I can do? I could go back to the do like the other question too. And that's the image not there. I could for this question and that other question, I could give credit for it.
Okay.
You know, like
Also,
say, well, it won't hurt the person. Yeah.
Okay. Number 43 as well. I had a question about that one because I thought I answered that one correctly.
All right. So what this saying? True or false? The following code correctly determines whether X, whether X contains a value in the range of 0 through 100.
Yeah.
Contains the value. If X is greater than or equal to 0 and X is less than or equal to 100. Yeah, that's supposed to be true. Let's see.
I thought this was a quiz question on the quiz we just took, and I thought I'm pretty sure I remembered it from that, but I can recheck if you'd like me to.
Right. But if it's greater than 0 and less than 100, well, greater than or equal of 0 from the range of 0, anything that's greater than or equal to 0 and less than or equal to 100. Yeah, that would be true. That would be true. If X is greater than or equal. if I put 5 is greater than 0, and 5 is less than or equal to 100. That's true. If X is greater, yeah, because if I wanted to do the range on the outer side, I would use R. Oh, no. See, I'm saying it right, but reading it wrong. Look, you got X greater than or equal to 0 and what?
And less than equal to 100. So that should mean it is between the range of 0
No,
and 100.
No. This is a C++ statement, right?
Yeah.
So it should say X greater than or equal to 0 and X.
Less than or equal to 100.
X, right, but it should say X, right?
Oh, Jesus. I didn't see the X.
Right. Yeah, now it took me a little while, yeah. So, yeah, and X.
Oh, wow.
Yeah,
Okay, I see it now. My bad.
Right. Because remember, we kind of looked at that when we first started looking at it. You can do that in math, but you can't do it in computer science. Right.
That's my fault. I didn't see the X.
Right. I didn't see it. Well, I was saying X, but I was looking at it without it. So yeah. So that's the reason why. Because remember, you got to have a comparison, like the X, and then the and you got to have another A and B or Q and whatever comparison. Right.
While you're here, if you don't mind, can you explain number 45 to me?
45. Here, this one.
Yeah, it says if A is equal to B, then the result is times equals 2, but A does not equal B.
Hold up. All right. So what happens is it says int A is equal to 60, right? B is equal to 15, right? Int result is equal to 10. Now, remember what we talked about, and remember comparison and assigning?
Oh, is this supposed to be double equal sign?
Right.
Oh my God, I can't believe.
Remember, if you put that single equal, that means you telling that A is equal to B.
Okay, I made a bunch of small mistakes then.
Right. And that happens when you code too, because man, if you write an if statement and you forget that equal, man, you could be like, man, why? Why is it doing this? I know I did it right. I know my logic is right, but the syntax has to be correct also. Yep. Oh yeah. Yep. That's what that is.
There was one more question I had if you got the time, but
what you got?
Okay, number 29. I couldn't understand number 29. It says int number, cn number, but you're entering 11. If number is greater than 0, C out, C++. If it's not greater than 0, else soccer is fun, C out, C out, C out. I answered C++ because 11 is greater than 0, but I didn't understand how the correct answer was C++ is fun on the else statements.
All right. Now, what did I tell you about curly braces?
Curly brace. Oh, is that
right?
Okay, that ends the program for else. Okay.
Right. The else, yeah. See, the else is only soccer. Because there's no curly braces, you understand?
Yeah, okay.
So what happens is the number is greater than 0 because it's going to output C++. The else says, okay, well, soccer is the only thing, so continue on with is and fun.
Okay. Well, that makes sense because I'm looking at number 13 now, and I think that's the same reason I got that wrong too.
Oh, yeah. Okay. Yeah, man, that's programming, though, but as you work with it, you're going to get better. You know what I'm saying? And then the thing is, if you keep working with it, going through the notes or whatever, at the end of the semester, I take all of the tests, and your final come from all of the questions. So when you start looking at them, evaluating, like, okay, does this have whatever? Is this because you could have a question that's similar but not the same. But still, if you understand the logic, you know that, hey, wait a minute. I remember on one question they had this because this wasn't whatever, and that don't do whatever. You know, you understand. Yeah. So you're going to be able to take, and then you're going to be able to take the test again like I say, it might randomly pull questions. Like the last week of school, I'll give you an opportunity to take all the tests one more time.
Okay, awesome. I
Right.
appreciate that.
Right.
Well, that makes sense for number 7 too, because that's also where I messed up.
Oh, okay.
Yeah, I made a bunch of small mistakes.
Right, little bit of mistake, yeah. Well, that's why I say though, take your time and what you do, whether it's midnight, whether it's 10 o'clock in the morning, whether it's 3 o'clock in the morning, whatever. Find a slot where you say, well, man, I'm gonna take this test, I'm rested or whatever. I ain't gonna have no kind of disturbances, and take your test. You know what I'm saying? Because if you try to rush, man, computer science, when you rush, man, you're gonna make them little bit of mistakes. Yeah.
One last question. I promise I'll leave you alone for today.
What's that?
They opened up enrollment for next semester. Do you teach the next class?
Which one?
1194.
Yeah, 194. Yeah. Now, some semesters I don't teach it, depend on whatever. But most times I do, because right now I'm teaching 2 sections of it this semester. But what may happen, it depends. Because what we doing, man, they keep adding new classes, so we gotta fall into teaching these new classes, and then we got we get other teachers to teach the other classes. But sometimes if the class fill up, they'll say, okay, we create another section, and then they allow me to teach it. You know what I'm saying?
I gotcha.
Right.
Well, I appreciate you looking at all that for me.
Oh yeah, no problem. Yeah. All right. I opened up those assignments too.
Okay.
Yeah. All right then. But have a good one, man.
You as well. Thank you.
All right, later.